On 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 today on on today's Maker Mashup, we're building the X501 3D printer. So on today's Maker Mashup, we are starting part one of our X501 build series. Now, if you've followed the channel for a while, you know that we have an X301 printer, which is a CoreXY DIY printer, and you can build it yourself. We have also put together an X201, which is a slightly smaller version, and that one's really great if you don't want a big printer. But one of the things that, since we put together the X301 videos, that everyone has asked for is bigger. Everyone wants to scale this printer up and make it larger, and that's what we're going to be doing in this build series. So part one is going to cover the construction and a lot of the linear motion that's involved with this printer. And then what we're going to do is have each one of these videos do a little bit more. So at the end, we'll have a working X501 printer. So there are some design differences to the X501 from the X301, and that's what we're going to be touching on largely in this video. If you want to know how to assemble this printer overall, you could just go watch the X301 videos, and there's a card up at the top that'll link you to the build videos for the X301. If you want to build an X201, which is a smaller version, it's essentially the X301 with a couple of part changes because they're smaller. Now the X501, that means that we've got a much bigger printer, and it changes some of the rules on how we had to put this printer together. We couldn't just make a larger version of it because you would have had far more flexing in the longer lengths of the extrusion. So that's where you see things like this back plane that is here, and we've had to add some additional brackets here to hold this extrusion in place to make it much more rigid than if we were to just copy the X301 design right from the start. So the goal of the X501 is to be able to print large things, but not take longer to print those large things. Now what I mean by that is an X301, for instance, a 0.4 or 0.6 nozzle is pretty commonplace for a lot of the X301 builds. For the X501 build, we're talking about a 1mm nozzle as the base nozzle for building this printer. Now, why such a big nozzle? Because when you get to 500mm and you want to build something that is in that very, very large space, it would take a very, very long time to be able to print something at a 0.4 nozzle height. So the idea behind this is that we built a printer that's much larger, but it's also designed to print large things in the same amount of time with not the same level of granularity or fine layer lines that you would find on something like the X301. So this printer is designed to be something a little bit different. And if you're considering building one of these things, you really should understand that if you're going to throw a 0.4 nozzle on it, it could take your prints 4 or 5 days, even a week to complete if you're printing slowly and want a super high quality print at a very small layer height. Now that might be your goal and you may want to go down this route for that, but that's not what I'm building these videos for. The idea here is to build something that can print at a fairly fast rate to build things like furniture or other things that are more real-life objects that you would not be able to normally print with a standard 3D printer. So that's really my goal here for the X501. So the build series is going to work a little bit different. I'm basically going to be showing some of the part changes that we made, and some of these parts can be used on the X301 or the X201, but basically what I'm going to be doing is going through this as here are the changes that you need to make to a standard X301 build in order to turn it into an X501 build. So with all that said, let's get to work. Like the X301, we're going to start with the base electronics enclosure. And we're once again using the inside corner brackets that are hidden inside the extrusion. Now the benefit of these corner brackets like this is that they do hold very tightly and keep things from flexing, but you can use a standard corner bracket as well on these corners. And while we assemble this, we want to just get these assembled and then make sure that they are just lightly tightened. We just want to keep everything together until we get it onto the base plate itself. Now here we have one of the laser cut base plates, and the real advantage of this is all of the holes are lined up, and this time around I don't have to drill anything. The first step here is to go around and preload all of the screws and feet onto this main plate. Now the real trick here is that once you get everything all set here, because this is all laser cut, it's all square. So this works really well for lining up and making sure things stay square. So once we go ahead and put all of these different screws in here and get this loaded, we're going to attach this to the base plate, and then we'll tighten everything up, and that will keep everything square for us, so that way the rest of our build is square and rigid. Now we're going to measure everything here, and then we're going to go ahead and install our 40/40 brackets for the main sides here, and then after that we're going to go ahead and install the rear 2020s. Now so far this is pretty much the same way that you're going to make a 301 build. Nothing's really changed here except that we are using bigger extrusion. Now that we have the base all complete, now we just have to do the top half of the frame. So we're going to add in here our plastic corner brackets that we've 3D printed. We're going to get our extrusion slid in here for both the left and the right. And then we're going to go ahead and finish everything off by going ahead and attaching the 2020 to the 2040. And then that will complete our main frame construction. In order to add rigidity, we put that new backplane in place. Now to do that, what I'm going to do here is tap out a M5 screw out of the extrusion here of the 2080. And we're going to do this on both sides. And then after that, we're going to go ahead and attach the backplane. Two of them are going to go to the 2080 that we have here. And then the other two are going to go ahead and attach to the upright 2020s. And that adds some solid rigidity to the overall design. Now we're going to move on to the stepper mounts. We'll get those attached to the extrusion, and then we're going to go ahead and install the rear pulley towers as well. These just go ahead and screw into the back of the plastic of the extrusion. And now we move on to the linear rails. We want to make sure we get these all lined up. 600mm rails are really long, so I had a few extra screws on this when I went ahead and assembled it on each side. Once the linear rails were in, I went ahead and installed the stepper motors. Now it's time to move on to our Z-axis. This goes on pretty easy. We just go ahead and make that flush with the 600mm extrusion, install the bracket for our bed mount, and then we're going to go ahead and install the stepper motor at the bottom. Once that's all done, this lead screw takes forever to feed through. It is a 2mm pitch. This took a really long time, and I sped it up 1,300 times for the video. Once that's all done, go ahead and tighten things down. And then once that is wrapped up, we're going to go ahead and move on to our X-axis. This just drops right into place, and we're using the new and improved X-axis mounts. These upgraded mounts are available in the LayerFused repository, and you can add them to your X301 or X201 builds. Now we're going to tighten this down, and then we're going to move on to the pulley towers. For this build, I chose the iron red color from the LayerFused Pro PLA. I wanted to use something different since we had a blue and a black model already. Once the tower is in place, you're going to want to go ahead then and install the carriage plate. And then finally, once everything was all aligned, like I said, I went back here and installed these corner brackets to add even more rigidity. And I added them to all the 40/40 and 20/20 that we had going upright. So as you can see, building an X501 is very much the same as building the X301. There are some key differences and some things that you're going to have to do in order to add rigidity. Now, you don't have to get this back plane. We will offer this in the LayerFused store, but you don't have to get the back plane if you want to reinforce this in another way. The whole idea here is that you don't want to have any shifting of the 3D printer in any of the directions while it's printing. Otherwise, it's going to throw off your 3D prints. Now, I went with the backplane approach. Now, other people have been talking in our Discord channel for a lot of our insiders and Patreon members. We've been talking a little bit. Some have also suggested just using reinforced aluminum at different angles to create an X where it can't shift left and right. I like the backplane approach because it screws into both the bottom and the top, and it's a nice addition aesthetically. It looks really nice seeing the logo there and being able to have a backplane on it to hide some of the wires. Now, as the X501 progresses, you're going to see other changes like that, and I've got a pretty good plan for how all of this will go together, and we're going to learn together how this all works once we get it completed. So with that is going to bring the end of today's video. If you liked it, make sure you mash that like button and don't forget to share and subscribe so you don't miss any of the upcoming episodes on the X501 printer. If you'd like to help support the channel or you want to become an insider, please check out our Patreon page. The patrons get early access to all of this content, and a lot of them have seen the X501 coming for some time, so I'm really excited to start putting these videos series together so that way everyone can see all the results of what we've been talking about for the last 4 or 5 months. If you're interested in this printer, don't forget to check out our Discord channel. It's a very large makerspace, and we're coming up on 1,000 members in our Discord channel where we talk about 3D printers, CNC, lasers, electronics, just about anything. It's really a great place for makers to share in real time their experiences and also get help with a lot of their projects. And I have links for all that down in the description. So with all that said, I want to say thanks again for watching, and we'll see you all next time.